All right, so we're talking about domain and range again. This is the third day. One of the days was kind of really short, but on domain and range. By now, it should be really easy. If I ask you the domain and range of this, a picture should be like, ha, domain's so easy. It's just this way to this way. So what is the answer? Negative infinity to positive infinity. How about the range on this one? How low does it go? Negative infinity. How high will it eventually go? Positive infinity. All right. So here is how I can make it a little more challenging. Let's say that I wanted to say that it got to this point right here, and then there was an empty spot. It's going along, and all of a sudden, oop, there's no answer right there. That's called a hole. I have to say that carefully. Otherwise, I might say a hole. Anyway, if I go into that spot right there, there's no answer there, right? So if I'm going to say the domain of this thing, I would say now that it's got the hole there, the domain is from negative infinity until where does it stop working? And be careful, 2 is correct, not 50. Because domain is this way to this way, and it doesn't matter how high it was, it matters how far over it was. It stopped at 2, and then it started working again at just after 2 and went to positive infinity. Do you get what I'm saying? So if you remove a spot doesn't work, then it's going to have a blip like this, and you'll have to write out 2 sets of answers. Yes, sir? What would that look like on a function? It would look like this. Let's see. It would be x minus 2, actually. It would look like this. If there is something on the top and the bottom that cancels, that's what creates a hole in the graph. Because as soon as I hit 2, you see how there's a 2 here? As soon as I hit the 2, the bottom becomes a 0, and whenever the bottom becomes a 0, there's no possible answer. You get that? All right, so that's how a hole could actually happen in a function. Okay, so back to, if I put that hole there, I'd also have to put one here and here to ask you the range question. If there's a hole here, here, and here, I want you to write down what you think the range of this function would be then. It starts at negative infinity, and then it comes up, and then, okay, write down the range, please, right now. If you don't know, then you're missing something. You're not paying attention quite well enough. I always want you to be thinking like arrows. This is all the way the lowest it can go, and it comes up, and then all of a sudden it hits a spot that doesn't work, right? See it right across here? Once it gets to that level, it doesn't work. And then it starts working again and goes on and works forever. So it's negative infinity to 50, and it doesn't work at 50. And then it starts again at 50, and it goes to infinity. Raise your hand if you had that right. Okay, good. All right, moving on. This one, domain, just say it. Negative infinity to positive infinity. How about the range? Negative 50 to infinity. All right, good. What if I put an empty spot there, there, and there? My domain now has a whole bunch of chunks. It's negative infinity to, in case you don't want to count this out, it's 2, 3, 4, 5, negative 5. Negative infinity to negative 5, and then negative 5 to 2, and then negative 2 to 1, and then 1 to infinity. The range would be simpler. The range is from negative 50 to 0, and it doesn't work at either, oh wait, it does work on the 50 end. Doesn't work at 0, and then 0 to infinity. All right, I guess, unless you thought this didn't go on forever, but I'm assuming it goes on forever. All right? Okay, so that's the kind from a picture, and they're really easy. Now, parent functions, things you should be able to recognize. If you were given this, and you were asked to find the range of it without any kind of a picture, you should be able to picture it in your head and be able to say its range pretty easy. Can you picture that? What shape is it? It's a V. And has it been moved? Which way? Up 5. So it's a V that's been moved up 5. So it looks kind of like this. And now I can tell its range really easy. It goes from where to where? 5 to infinity. All right, good. What is that crackly noise? I don't understand it. Okay, I just have to move the cord around and then it stops for a while and then it starts again in like 3 minutes. I think it's static electricity buildup, but I don't know. Okay, this is a parabola because it's got a squared. And there's a 2 and a 3 and another 3, and it means that the parabola has been moved some places. Where? Well, this means moved where? Left 3, this is. Down 3, and this is stretched which way? Up, down, or left, right? It's up, down. I'm glad we talked. Stuff on the outside here, up, down. Stuff on the outside here, up, down. Stuff in here only is left, right. Okay? So that is an up-down stretch. So it's twice as tall as it was. So it's like you grab the ends of the parabola, like here, and you grab on it and you pull them up. They go up higher than they were before, and the things tend to get skinnier. All right? So the most complicated kind are the kind in the middle, because then they are left-right kind of stretches, but you can't trust them. That's a parabola that has been stretched left-right. But is it wider or narrower? Narrower. You would think it would be twice as wide, but it does the opposite of what you'd expect. So it would be half as wide. And you would think it's been moved to the left, but it's really moved to the right. You get that? Okay, so there's some stuff about your basic ones. Here's one of the ones that was kind of only introduced last year. It's the 1 over x function, and it's got those blue lines that start with an A. Do you remember what they are? Asymptotes. And so now this is the first function where you could honestly say, look at the asymptotes on that mother function. All right. So if I move this over 3 and up 1, then I could say over 3 to the right is like minus 3. And then how about the up 1 part? Up 1. What do I do? Plus 1. Good. Okay, so that's another function that you need to know. Now, these are trickier to read for the domain and range. But it's still, if you follow the way I've been telling you, think about how far does it go this way, and then like travel with it back this way until you hit glitches or whatever, and then see how far it goes that way. Okay, so domain would be from what to what? Negative infinity until it hits what? Not 0. The one I got on the board here, it hits 3 and has a problem. Then it starts over again at 3 and keeps going to infinity. You get that? How about the range? Negative infinity, and then it keeps coming up until it hits what and when it has a problem? 1. And then it starts over again at 1 and goes to infinity. Good. All right. Was there a hand? Any questions still? Yes. All right. An asymptote is something that you can never be, like it's usually something on the bottom like this. You know how I could never use 5 in a function that was like this? Because it would cause a 0 on the bottom. Okay. An asymptote is different because it would only have that and it would have nothing on the top to cancel it out. This would be a hole if it cancels like this. And it would be an asymptote if there was only the bottom part and there was nothing canceling it. That's an asymptote. That's one way to think of it anyway. Okay? You aren't expected to know this yet. I'm answering your question, but we're actually teaching that in a few days. So, and it'll take like a day to explain all of that. So that's just the quick answer to your question. All right. So here's a typical problem. That's a domain question, and you don't know what the picture looks like. And you aren't expected to graph it, because once you get a graph, they're really easy. But if you have to do it without a graph, and some of them are really complicated ones, you'd never be able to graph by hand, then you have to be able to ask yourself 2 questions on domain. Would you please write these down? Domain, you ask yourself, Are there square roots? And the second question, is there denominators? If it doesn't have a square root in it and it doesn't have a denominator in it, then everything will work. So if I had a function like this, it doesn't have a denominator and it doesn't have a square root, then everything works. So what's the domain? Negative infinity to positive infinity. Everything will work. There's no number I can put in here that will screw it all up. But as soon as I take this and I like divide by x, then it has a denominator. I have to watch out. On the denominators, what can't they be? 0. So I just have to say that the denominator here, x, cannot be equal to 0. And now everything works except that. Okay? Next step, let's say I put this under a square root. Now this problem has two things to watch out for. The denominator can't be 0, that's this part, and the square root part can never be negative. Well, in this case, can you think of any number you could put in here that would make this come out negative in here? No, there's no way to screw that up. See what I mean? All right, but I'm going to make one so that you could. Let's say it was 5 minus x. Now, there's a lot of numbers I could put in for x that would mess this up. There's a lot of numbers that would work, but there's a lot of numbers that would mess it up. All right, so how do I approach a problem that's got multiple things that could screw it up? First, you do it one step at a time. You start by asking, is there what could mess up my denominator? And you write it down. And you'd say, okay, x cannot be 0. And then you take the square root, which is right here. And you say 5 minus x has to be greater than or equal to 0. And then I get my key points. 0 is obviously a key point. The other one, I'm going to add x to both sides. That gets the x alone and positive all at once, which is kind of cool. But it's kind of annoying, isn't it, to read these backwards? So to me, I would flip this and say x is less than or equal to 5. It's the same exact thing as what I just had a second ago. All right, so what I just figured out is that x has to be not 0, and x has to be less than or equal to 5. That is really hard to write a domain based on that. But if I make it a number line, remember how yesterday I said if there's one thing you leave here with, it's that you should know that you should make a number line for these problems? All right. What number should I put on my number line? 5. And what else? 0. Does it work at 0? And if you're not sure, I know it says x is not equal to 0, but some people are seriously not going to know if it works or not. Well, then go stick in a 0 in the original problem. Would a 0 mess it up? Yeah, you try it and you realize, oh, the bottom's going to be 0. That's a problem. Doesn't work here. Empty spot. You know what? That's a good point. Let's do that. That will screw me up eventually if I don't do that. Thank you. So the 0 is not working now. Now, how about the 5? The 5 itself, is the 5 okay? It says x is less than or it could be equal to 5. So it works. And if you weren't sure, what would you do? You'd stick it back in the problem and say, does it cause a problem? A square root of 0 is not a problem. It's just 0. All right, so now I got to figure out, does it work here or here or here? You just try numbers. What's a number that's in here? 4. 1. Okay, 1's even easier. Let's try 1. Okay, so if I'm going to put in a 1, 5 minus 1, does that cause a problem? No. Having a 1 on the bottom, does that cause a problem? No. So it works. So it works in there. Next, you test and see, does it like work here? Let's try 6. So if I stick in a 6 in my original problem, I stick a 6 right here. Ooh, that's weird. I guess I can move my 1s out. I'll put a 6 right here. Is that going to cause a problem? Yeah, why? Because that comes out to negative underneath the square root. So I tested it, and 6 was a problem. It doesn't work there. And then I should test negative 1 and see if that's going to be a problem. If I put a negative 1 where I had the 6 here, negative 1 there and there, is a negative 1 going to cause a problem? Oh, because 5 minus negative 1 makes a positive and underneath the root, and that can be negative on the bottom. That's okay. The bottom's can't be 0. So it worked out there. But remember, it didn't work at 0. It was an empty spot there. So I would write negative infinity. Now once you're all done, see, isn't it easy to write these domains now that I got the picture? It's easy. I just say negative infinity to 0, and it doesn't work at 0. Union with, it starts again at 0, and it goes to 5, and it works there. And then there's nothing else, because it doesn't work after that. So there's my answer. So one step at a time. You ask yourself, does it have any square roots? You ask yourself, does it have any denominators? And then you make sure that you can fix them easily. All right, does this problem have any square roots? Yes. So I have to right away set this greater than or equal to 0. And I got my key spot. Once I got my key spot, I put it on a number line, and from there it'll be easy. Look at this one. Does it have any potential problems? What could be a problem? The square root. So I set that what's under the square root to be what? Not 0. Greater than or equal to 0. Okay. So I'd set negative 2x plus 3 greater than or equal to 0. Because remember, it can be 0. All right. This one. It's just a range question. Remember how we talked about these at the beginning of the hour? What shape is it? A V. Where's it moved? Is it stretched a little bit? But that doesn't change how tall it is. So it's still a V that's been moved up 1 and is a little bit stretched. But it's like this. And so then what's its range? Its range is from 1 to infinity. All right. These domains. Does this one have any potential problems? No. So it's negative to positive infinity. Done. Does this one have any potential problems? Yep. I'd have to set what's underneath the root to greater than or equal to 0. This one, have any potential problems? It's the bottom that could be a problem. So I set, this is important now, I have this on a separate slide right here. I would set this one to x minus 6 has to not equal 0. You're probably not used to solving equations with not equal in it, but they work exactly the same. Add 6, x is not equal to 6. So x being 6 would be a problem. Everything else would work. So you draw a number line and say x can't be 6. Empty spot works here. And if you weren't sure, test a number. And then you can easily write the domain from that. Negative infinity to 6, and then 6 to infinity. Okay, this one, potential problems? Yes, 2 kinds of potential problems. So you write them both out. You say both x squared minus 9 has to be greater than or equal to 0. And you'd say 2x minus 1, and what do I write for that? Not equal 0. You get the difference there? All right, I'd like you to finish this one, please. Just tell me what you think the final answer is. Okay, now what? If I square root both sides here, I hope somebody's going to tell me to be careful on something. Yep. My answer is absolute value of x is greater than or equal to 3. I know some of you forgot that, and there you goes your R3 question. You just got it wrong, because you need to divide this into 2 parts. X is greater than or equal to 3. X is less than or equal to negative 3. Then this part, add 1. 2x not equal to 1. X not equal to 1/2. Seems like I got 3 important numbers here. Boy, this is getting confusing. What should I do with those 3 numbers? Pick a number line. Put on negative 3 and 3. And a half is in there somewhere too. Maybe I should put the half here. And then I make sure, no, it can't be a half. It says it right there. So I know that's empty. Can it be 3 and negative 3? Yeah, it says so. It says could be equal to. And the last thing is, this kind of gives me some hints. It says bigger than 3. So it probably is going to work out here. But I really should test something. I'll test like 4 and make sure it works. So I go stick 4 back into this original equation right here. And I would find out that 4 is just fine. It works. Doesn't give me any negatives under square roots. Doesn't give me any zeros in the bottom. Some people ask me, what is this thing supposed to equal anyway? I don't care what it equals, as long as it doesn't equal 0 on the bottom, and as long as it doesn't have a negative under here. I don't care if it comes out to a bazillion or if it comes out to 7. It doesn't matter what it comes out to. It doesn't have to equal anything. It just has to not break. And it breaks if there's a negative down here, 0 down here, or a negative in there. So otherwise, it can come out to anything you want, as long as it's not negative under the root or 0 on the bottom. The final answer is, it worked up here. Has anybody tested something in here to see if it worked or not? Doesn't work? Okay, I'm going to double check you. 2. Put in a 2. 2 squared is 4. 4 minus 9. Yep, I got a negative under the root. Doesn't work. All right, has anybody tested something in there? Work or not? Okay, a lot of people said no, I'm going to trust you. And how about negative 4 or something like that? Anybody test that in? Does it work? All right, I'm just going to double check that one. Negative 4. I stick in a negative 4 here, but it's getting squared, and the negative will become positive, and so then it's okay. And as long as the bottom isn't 0, which it wouldn't be, then I'm fine. So that works. But the bottom can be negative, and it won't be a problem. No. Negative 4 times negative 4 is positive 16. You were thinking times 2 instead of times itself. It's all right. Thank you for checking. At least you were paying attention. That's good. All right. So now, final answer. How do I write this? I'd say from negative infinity to negative 3, and it works at negative 3. Doesn't work there. Union with starts working again at 3 all the way to infinity. So these have lots of parts to them. But the main things are, look for square roots and set them greater than or equal to 0. Look for these, set them not equal to 0, and get your magic points. Once you got your magic points, you can test the intervals and see where the answer is. Okay? That's how you find a domain algebraically. All right, so here's one last one. Give it a shot. I think this factors, which will make it a lot easier. If your pencil is not touching the page, you are not doing this problem. Two x and x is how I'd start. Anybody found it? Like this. I'm going to double check you now. First, 2x squared. Outside, 8x minus an x makes 7x. Yes. And the last make negative 4. Yep. Very nice. So now, what are my answers? My magic points are 2x minus 1 has to not equal 0. And x plus 4 better not equal 0. Because if it does, no wait, it actually equals 0. I'm sorry. 0 is okay. I forgot that. And I'm under a square root. And under a square root, it's okay to have zeros. So then, this is 2x equals 1 and x equals 1/2. And over here, it's minus 4, x equals negative 4. Those are my magic points. 1/2 and negative 4. Man, I could even guess and be better than this. Almost always put it in the right spot. Okay, wrong spot. So there is my number line, and now I just have to test some points, like try 0 and see if it screws anything up. If I put in a 0, is it going to be okay? Nope, because it's going to be negative 4 under the square root, so that doesn't work. If I put in 1, is it going to be okay? 2 times 1 squared is 2, plus 7 times 1 is 7, minus 4. Is that going to be okay? Yeah, that's going to be all right. So that worked out there. How about the 1/2 itself? That's going to make it equal 0, right? That's kind of the point. And is it okay for the square root to be 0? Yep. So it works there, and it works there. And I bet you it works out here at like -5, but I don't know, so I'm going to test it. So I stick in a -5. 2 times -5 squared plus 7 times -5 minus 4. And I hope that never doesn't come out negative. And I get 25 times 2 is 50 plus -35, which is like 15. 15 minus 4 is still going to be positive, so I'm good. So it worked. So it's from -infinity to 4 and 1/2 to infinity. Get how to do these? All right. Then that's enough learning for today. Here's a worksheet.